if you purchase any cake, no, in the cake, how that any dry fruits that will be embedded, or cherries, that one. So similar to that one. So here like this, the electrons will be embedded. The positive charge will spread it throughout the volume, and this one. So altogether, it says the atom is electroneutral neutral, as it was justified. Then he proposed that negative charge is what electron, and that negative charge is not at one specific point. it is like a embedded. So atom is electrically neutral. Positive charge is spreaded throughout volume of atom. Negative charges embedded in it. This one. Next, what are the things? Why do that thermionic emission occurs here? So I'll start eating it. Then the electrons will happen, they'll gain sufficient energy, and when the kinetic energy becomes greater than that binding energy, so then what happens, the electrons will escape here. So what are the things? It clearly explains thermionic emission, and most of the things like any molecular, so like atom is electrically neutral, which all supports that particular molecular structure, that was able to explain here. What is the biggest problem is the hydrogen spectrum. I think by the time at the end of the 19th century, we have the idea of the hydrogen spectrum. It failed to explain hydrogen spectrum. So it could not explain, because hydrogen spectrum is a line spectrum, will I agree? It's not a continuous, it's a line spectrum. Because only the radiations are of specific wavelength will be seen in the hydrogen spectrum. From where that hydrogen spectrum is available? From sun's radiation. And the sun's radiation, what when we are able to plot that. So we are able to start, by the end of 19th century, we are able to measure the wavelength of the EM wave. Then with the help of that, they constructed hydrogen spectrum. And according to this, what happened, how do that hydrogen spectrum, so according to this particular model, there's no any such thing like a, how that spectrum has come. Only few chemical properties, and atom is electrically neutral, electrical properties, and few some chemical properties it was able to explain, and thermionic emission. So these are the things like electrical and chemical properties. It was able to support chemical properties and electrical property, how that current will flow. The particular, these electrons are responsible for flow of the current. Then electrical properties, fine, and thermionic emission. So these are the things which was, so these are the some phenomena what happened which were supporting this particular model almost till 1911, almost from he proposed in 19, I think 89, almost for 20 years. What happened, just what all the applications were there, no, some applications what happened, they were, with the help of that applications what happened, this model was supporting that one. This was the Thomson static model. So there was nothing called like a nucleus, no idea of nucleus here. And what are the drawbacks here? It was unable to explain, what first, hydrogen spectrum. According to this, continuous spectrum, but hydrogen spectrum is a line spectrum. There's the one thing. There's a very nature, that one. And next, what about the ion? So thermionic emission means when all the electrons are ejected, then what happens? It will become an ion, that one. So the major properties like a unable to explain the hydrogen spectrum. So therefore, what happened? Hydrogen spectrum is a basic thing. So therefore, they were started thinking what can be the reason. Then the Rutherford, what happened, suggested another atomic model. Rutherford's atomic model. So what he did